So Dr. Sadhan Kumar Ghosh, Professor in Mechanical Engineering and Chief Coordinator, Center for Sustainable Development and Resource Efficiency Management at Jadavpur University, India. He's a keynote speaker for our FTP, that is on novel application of waste technology systems for sustainable future on 2nd August. He also has served as Dean, Faculty of Engineering and Technology and Head Mechanical Engineering Department. He was the Director, CBWE, Ministry of Labor and Employment, Government of India, and Larsen and Torbro Limited. He is a renowned personality in the field of waste management, circular economy, green manufacturing, supply chain management, sustainable development, co-processing of hazardous and MSW in cement kiln, plastic waste, and e-waste management and recycling, management system standards ISO, and TQM, having 3 patents approved. He is the PI, Principal Investigator at JU of the European Union Horizon 2020 funded project, that is India H20. In the year from the year 2019 to 2023 to develop business models for treating domestic and industrial waste water to combat water crisis in Indian villages. Indo-Hungarian research project applied industrial research for the thermolytic recovery of sludge like waste for the circular economy and biogeochemical cycle, and OPTOCE research project from Norwegian funding from Sintef. The new project started in 2021. His research funding includes European Union, Erasmus Plus, UKIERI, Royal Society DST, uh, GCRF UK, Royal Academy of Engineering, Georgia government, etc. PI of International Research Project on global status of implementation of circular economy, that is from the year 2018 to 22 by ISWMAW, involving experts from 35 countries. Professor Ghosh is the founder chairman of the ICON SWM, that is International Conference on Sustainable Waste Management, International Society, President of International Society of Waste Management, Air and Water, ISWMAW, and the Chairman, Consortium of Researchers in International Collaboration, CRIC. He received several awards in India and abroad, including the Distinguished Visiting Fellowship by the Royal Academy of Engineering, UK, to work on energy recovery from MSW. He wrote 10 books, 45 edited volumes, more than 250 national and international articles and book chapters, and was associate editor of special issues of WM and R and IJMCWM. His significant contribution has been able to place the name of Jadavpur University in the world map of research on waste management. He is the editor of Circular Economy Global Perspective, published by Springer Nature and CE. Recent Trends in Global Perspective is expected to release in September 2021. He is a consultant and international expert of UNCRD slash DESA, DESA, Asian Productivity Organization, Japan, China Productivity Council, then SACEP Sri Lanka, IGES Japan, etc. He was the convener of ISO TC 61 WG2, member in the Indian Mirror Committee of ISO TC 207 and ISO TC 275. He was recently developed he has recently developed the BIS a standard on e-waste storage, collection, and also recycling. Presently developing the guidelines for addressing resource efficiency, secondary raw materials, and circular economy in standards. He is expert committee member for the preparation of standards for RDF, for utilization set up by the Ministry of Housing and Urban Affairs, MOHUA, Government of India, chair-elect of 10th ICON SWM-CE to be held at SVU, Tirupati, India in December 2020. Okay. So this was the introduction of today's keynote speaker. Before starting, sir, I just wanted to inform you, the entire session would be of 2 hours. So first was 1.5 hours would be for you to deliver your talk, followed by 20 to 30 minutes of interaction with the participants. Okay, sir. Thank you.
Thank you very much.
Thank you for accepting our invitation and delivering a talk in this particular FTP. You can say the virtual stage is yours, sir. All yours.
Thank you. Thank you. Thanks for inviting me for participation in this program. And I especially thank to Jyotirlaxmi and the department for taking much effort for a successful program on waste technology and management. And of course, I kept my time up to 11:15 because I have another meeting. It was scheduled from 9:15 to 11:15. So I'll stop at 11:15:20. Okay. This topic is very relevant today because you know that we are extracting more resources than what should have been. So that creates the problem of the whole world. And we are thinking about how the waste technology and waste management can be implemented effectively. Today's topic could be like this, greening chemistry, introduction, waste generation and management, circular economy in Indian legislation. Some innovation, I'll show one or two of my work, innovative work, which have been implemented in waste management, and then resource recycling technologies that can conclude. So why we are interested more on waste technology and waste management? Because if we look into the data of last 40 years, we'll find that the extraction of the material is so much which had been in the world. If we talk about 1970 to 2017, then it has been observed that from the 2007 billion ton of extraction in 1970 has come to more than 90 billion tons, which is more than 3 times, and which is really a problem for the society. And not only that, if we go on extracting the material in this rate, by 2050, we will find that the material extraction will be more than double, and which is an unsustainable developmental process. So the first thing which we have to do is reduce the extraction of the natural resources. And of course, the policymakers, implementers, researchers thought of, and in 2015, Sustainable Development Goal, which includes 17 goals, have been devised, and those are in implementation. And most of the activities which are carrying out today, knowingly or unknowingly, those are supporting the sustainable development activities, development goals. What's about India? We have seen that India, being having the biggest population in the world, and which are now tying with China, we have a more amount of extraction, whereas the average world extraction rate is 450 tons per acre. But in India, we have a figure of 1,580 tons per acre. So it's more than 3 times. And with respect to the resource recirculation is concerned, we are not in a good position. So what is happening, whether it is water, whether it is materials, whether it is energy, India is spending a lot. And as a matter of fact, the extraction is also more. So the recycling rate, whether it is water use utilization, whether it is wastewater treatment, whether it is the carbon emissions, everywhere, India is trying to reach certain level which helps in reduction of the extraction of natural resources. And all of you who are here and who are not here but concerned more about waste management, circular economy, green chemistry, or any other thing, those are all focused to the reduction in natural extraction. So in that way, we should be very careful about it. And we have to always try so that our extraction process is not accelerated by our own activity. If we look into this figure in the table, we'll find that there are a number of countries on our left, but whenever we talk about the utilization of material and the generation of waste, we will find that the waste generation in each of the countries, we have a figure. But what is the per capita, per person generation? In Bangladesh, whenever it is 0.43, which is near to India, 0.5 on an average. But you see that Portugal, it is 1.26. If you consider USA, it is more than 2 kg per capita per day. Brazil, 0.972. So in that way, in India, we are quite well ahead of many other countries who are at par, like Brazil's economy and our economy is more or less at par, whereas Brazil is having more waste generation, more waste generation and more waste per capita generation than India. What's about this waste? Are these going to the landfill? Are these going to a place where there is no possibility of utilization? Yes. If you go to the last column, you will find that the countries, many of the countries like Bangladesh, they are disposing 82% or more waste to the landfill. Landfill means these are not engineered landfill. These are simply dumping. So whenever we see that a lot of things are being dumped in the dumping yard, we have to see that whether there are any possibility so that we can do more towards the sustainability of our globe. What's about India? I'll come to India later part. But you know that South Korea is a country in 1980s, first half of 90, it was like India. They were producing waste and they were dumping waste in different dumping yard and landfill site. But what they have done, they have going for a recycling society. And as a matter of fact, the legislation and other part in Korea, the awareness, the involvement of the people, the research, the governance is such that by 2016, they reached a state where they were only disposing 15% little more of the waste to the landfill. And they had a target that 2020, they will go for only 3% of the waste to the landfill. Of course, this has not been achieved because of this pandemic situation, but they will be achieving very soon. So the difference between 82 or 97 and 3%, what is this? This is the utilization factor by which these countries are utilizing waste. So this is the main concern of today's lecture, not only today's lecture, next 5 days, whatever lectures will be there. The purpose of this is to reduce this gap, that whether how much we can utilize the waste which we are throwing here and there, landfill site, going for marine littering, going to water bodies, going to dumping site, and which creates problem for our agriculture, for our drinking water, for even whenever they're dried up, it creates problem for the air. So in that way, all these problems are lying in the waste which we are generating, if it is not recycled properly, if it is not taken care properly. Now let us come back to India. What is happening in India? I mean, let us see first what are the types of waste. There are a number of types of waste. I have just simplified it. Total generation in India is 1,236 million tons per annum. Which are there? The industrial wastewater, and out of this only little more than 50% is treated. So most of the wastewater, industrial wastewater, is going as a, going to the water body and whatever possibilities. Then the industrial waste. We are generating quite a huge amount of industrial waste from different factories, which is waste and some non-hazardous waste. Then the urban waste. The urban waste can be divided into again three. One is the municipal solid waste, sewage and sludge, and plastic waste. And there are some other waste like paper waste, metal waste, all these things. So I'm not going into the detail of those, but you know that as of today, we are generating around 62 million tons of municipal solid waste. And out of this, only nearly 35 to 40% of that is treated. But you know that this was 20 or 17% 6 years back. But due to the intervention of the Swachh Bharat mission, intervention of the revision of 6 rules in India, waste-related rules, revision in 2016, the intervention of battery rule, revised battery rule in 2020 in June, and all these things, and of course the EPR regulation. So all these things have made us going to be a comfortable position, and now around 30 to 40% of the waste are being treated in different cities. And I'm quite happy to say that the government of India could make 4,242 cities to come under the waste management ambit, and all of them are collecting waste. They are treating waste as per maximum as possible, and they are going for landfill with a lesser amount only. So sewage and sludge, quite a big amount is not treated. Around 25% is only treated, but there are every possibility that sewage and sludge that can also make us beneficial activities. I mean, even I have seen some of the factories in plants in Germany, where the energy is generated from sludge. And the plastic waste, of course, it's good that the India is very good in plastic business, and quite a high business, and it is third or fourth position in the world with respect to the plastic business is concerned. And the recycling percentage of plastic is very good. And I'm also very proud to say that 10 years back, the plastic bottles, PET bottles, was really a problem for us. And you could have, this could have been seen anywhere on the roadside or highways or rail station and others. But due to the intervention of Indian Railways and the beverage companies like Coca-Cola and others, they have now made that nearly 100% of the PET bottle is today recycled, and they are going for making some other products. And there is also a possibility that our PET, I mean recycled PET, this is being planned to use as a PET bottle as you are getting a new PET bottle. So as of today in India, that has not been cleared of, our PET, but in future, that will be an option for India. So PET bottle recycling is excellent in India and one of the best in the world. So there are electronic waste. Around 2 million tons of electronic waste is generated and only 5% is recycled. And the collection percentage is also very low. And I'm happy to say that the first recycling, e-waste recycling plant was established in Bangalore, the city where this course is conducted. And still now, that is the only one comfortable recycling plant in India. But there are some other recycling plants which are not bigger as that. So in that way, there is a lot more scope for the electronic waste to be recycled, to be collected and recycled. Of course, with respect to the electronic waste and plastic waste, the government of India has specifically for the electronic waste, we have incorporated the EPR, Extended Producer Responsibility. And in electronic waste from 2018, the Extended Producer Responsibility has already been implemented. And we can be sure that in next 10 years time, because you know that these are all new concepts in India which are coming. So for effective implementation, involvement of the people, specifically the involvement of the business houses and the manufacturer and the retailers, it will take time, but that is a good option, EPR in India. We have a major amount of agri-waste and biomass waste, 500 million tons or little more than that. And out of which, quite a huge amount is from the paddy and wheat. And this is a point for everybody today that the straw burning is a very, very crucial thing in North Indian areas, and it is creating a lot of problem in the air. And of course, it is also creating GHG emission in the air. So this is a concern for the people. This is a concern for the government of India, and we are also taking care of that. On the other hand, there are a number of plans in industry and in other areas, mostly as a byproduct. As a byproduct, you know that ethanol and many other bioenergy is being created or developed from utilization of the biomass, but that is very less. On the other hand, from the biomass, utilization of biomass and a part of the urban waste, those are also utilized for generation of gas and electricity through biogas plant or AD plant, which we call our biomethanation. But there are a lot of scopes for development in this area. Whenever we talk about hospitals and healthcare units, we create a lot of biomedical waste. And this, just 1 minute, please. Hello. Hello. আমি লেকচার দিচ্ছি, আমি ধরো 11:30 নাগাদ পাঠাবো, ঠিক আছে? So in that way, biomedical waste from the hospitals and healthcare unit, huge amount of biomedical waste is generated. And it's good that in 1988, the government of India has published the biomedical waste management rule. And this is one of the oldest rules in India with respect to other countries concerned on biomedical waste management. And the new biomedical waste management rule, the revised one, has been published in 2016. The implementation of biomedical waste management rule, mainly the waste which are generated in any hospital or healthcare unit, even if it is primary, secondary, or tertiary, the rule says that all the waste has to be separated and has to be collected and then treated. And in my opinion, as of today, biomedical waste management is the best business model in India with respect to any other business model with respect to waste utilization. So biomedical waste management in India is in quite good shape, and most of the 0.17 million tons of biomedical waste is collected and treated. But of course, there are some scopes always for improvement. Then comes this construction and demolition waste. You know that a few years back, construction and demolition waste was mixed with municipal solid waste. And that results in the poor quality of municipal solid waste, because whenever the construction and demolition waste is mixed with municipal solid waste, the whole of the essence with respect to the utilization in anaerobic digestion or with respect to the waste to energy plant, the capacity, the quality of the waste is totally, damaged. So in that way, in 2016, what we have done, we have released a separate rules for construction and demolition waste management. And today, it is neat, and it is as per the rule, each of the municipalities will have a yard where all the construction and demolition waste will be collected from household and business houses. And these waste will be recycled through the municipality or the government. And the responsibility of this is lying with the chief secretary of each of the state and the union territories. But it is very unfortunate that there are hardly the CD waste recycling plant in India. We have two recycling plant in India, which one in Delhi, which was installed in 2009 during the Asian Games, which is today having around 1,000 tons per day capacity. And the other one, which was installed 3-4 years back in Ahmedabad, which is having only 500 tons per day of recycling process, but huge amount. And more importantly, we don't have data. Whether it is 15 tons, million tons, or whether it is 500 million tons generation, nobody knows. So no reliable data and no reliable system of construction, demolition, waste management, and recycling. So there is a greater scope in India for having this in place. But again, I'll tell you that CD waste recycling is also a good business. Waste battery. Whatever I told about 1,236 million tons, this does not entail the battery waste and ELB waste. These two, though we have a battery rule, very effective battery rule, the battery rule was established in possibly 1999. And then the new rule, revised rule, the draft rule has been released in 2020 June. We are expecting the final policy, rules. But the battery waste management, not for the smaller battery, but bigger battery waste management in Easy India is very, very excellent. And you know that there is a EPR, like you cannot throw away the battery. It is also expensive. So the battery manufacturer or the installer or the dealer, they take back the waste battery and they give the new battery, like the take back of the computer and others in some of the places. But the problem is cadmium battery, small battery, the photograph which I have shown. So there is a huge scope for battery waste management for the small batteries. And I'm quite sure that the new rule has given a lot of scopes for business. So we are expecting that the battery waste is also will be in a good shape in next few years in India. What is ELV? End of life of vehicle. You know that huge car manufactured and sold and plying on the road. And in many of the government today, state government as well as the central government, in cities, no vehicle more than 15 years can ply. So they will not get the certificate of fitness. So what would be the fate of those cars after 15 years? Some of the cars will go to the rural area, but not many. So there is a huge quantity of end of life of vehicles. There are only one ELV recycling plant which is installed in Chennai, but of course, and in Delhi one plant. But you know that due to COVID, that Chennai plant was rescheduled. I don't know what is the reschedule because I sent some of my researchers to do some work on ELV recycling, but they could not be allowed to go inside the plant because that was not still running. And the other plant is India, but huge scope in India exists. So ELV waste management is another area which is a niche area in India, and that needs a lot of effort to take care of by the government. So in that way, this is in nutshell the summary of Indian waste management and the possibilities of business and recycling. One thing I always vouch for this, that waste management, the way it is running in India, the way it was running in India for a long time is not the right way. Because what was our policy, even in the government, that we look always waste management as a social activity. But waste management today should not be looked into as a social activity. It is a business. So whenever we look into the waste management as a business opportunity, it will work. But if we don't convert it into a business model, it will never work and it will always fail. So the researchers and those who are attending this program, I request your research to focus on how the waste technology or waste management or waste recycling can be converted into an effective business model. So that is the very important thing, and for which the promotion of the concept of circular economy is also there. There are examples in many countries, the implementation of circular economy has created a lot of business, created a lot of employment, and they could reduce the extraction rate of the natural resources. And the society becomes very clean. The city becomes very clean. And the water scarcity has been reduced. So these are the things which we have to be very careful whenever we do research, whenever we talk about and study this waste management and technology. So this is a data which I have shown about the generation of waste in different countries, rather. I'll show you, see, this is the waste management which is generated. And of course, this we are now generating around 1.3 billion tons, which is likely to increase to 2.2 billion by 2025, and so on and so forth. So on the other hand, if we look into the plastics, we'll see that that is also in 2019, the global production of plastic reached 369 million metric ton, and India generates 9.46 million plastic waste annually. And around 60% of it is recycled. Of course, the recycling percentage of plastic will be increasing day by day. And this is a good area of business because plastic recycling is also a very good business. You know that the plastic beads, that is the bigger business for plastic waste. I mean, this bead can be utilized as a substitution of the original bead of virgin material. But one thing we have to keep in mind that we are generating maximum waste. Like if you go through all this graph which I am showing, you will find that the East Asia and the Pacific and also South Asia, they are the maximum waste generator. See, these are the two. Like South Asia, we are only the 8 countries, and India is the big brother. Here, the major portion of this 334 and 661 in 2050, these are India is the contributor of maximum percentage of this waste. So we have to somehow reduce. If we go to this figure, we'll find that again, the same thing, East Asia, Pacific, and South Asia. So we are generating around 40% of the waste. And of course, this also relates to the income. So I'm not going to the detail of that, but one thing is very sure that if we don't have the income, then of course their possibility of treatment is less. But on the other hand, we have to look into the government and also the policymakers and researchers. We have a role to play that even if in the poor country, if we throw away the waste into the dump yard, then we are losing our scope of business. So in that way, we must understand that even if we are working in a low income group or lower middle income group, if we take initiative to recycle the waste which are generated, this creates business and employment for the poor people. So that should be one of our motto, and we are also working in India, we are also working with that concept. And again, the open dumping is around 33%. And out of this 33%, what? Mainly the food and grains. So plastic, glass, paper, cardboard, wood, metal, most of these are recyclable. Even food is also recyclable. Like I have visited one plant in Hong Kong. So what they are doing, they have a big factory. One or two, I have seen 3 factories. One, the food grade, because you know that the countries in East Asia, they make a lot of food waste. Like all the food, what they are doing, they are processing it and they are making food for fish, food for domestic animals and others. On the other hand, even they have the processing plant of the used oil. And from the used oil, they are again using some other oil for other purpose, not the food, edible oil. So in that way, there are possibilities. In India, I have not seen any food grains which are converting those into the animal feed and others, but there are possibilities, and it is a good business again. So I have seen that the food which are produced from that, it is in Indian rupees, it is around 100 or 120 rupees per kg. So these are all good business model. I was telling about the organic material. Now, if we talk about the electronic waste, we have seen that we are producing around 0.17 million tons of electronic waste per year. So in the world, we have also a good value chain of this electronic waste. If we talk about 49 countries in Asia, we are producing 44.7 million tons of electronic waste. And out of this, again, a few percentage of the world waste is recycled and collected. So there is again a huge gap between the production of the waste as well as the collection and recycling of the waste. I visited a number of recycling plant in, I had some interaction with the Bangalore e-waste recycling plant, but whenever, that was long back, but whenever I visited the recycling, e-waste recycling plant in Weiser, that is near Oxford in UK, and also, and some of the plants in China and Taiwan, I was really astonished the way they are handling this electronic waste. And number of good mementos was given to me, which were produced from this electronic waste. Those are very expensive. So in that way, I mean, we know that in electronic waste, there are a number of components, gold, silver, and many other metals. But what we are doing I can show you some photographs. However, I don't know where it is. But you know that we have to go forward with the possibilities of the business with respect to electronic waste. And today, the electronic waste, you know that electronic waste will not be seen in a good amount on the roadside or the waste dumping. But what is more important is these electronic waste are collected, and these are going to unstructured recyclers. What they do, they burn it, they put it into the acid, and they take the material out of it, which is not efficient process. And then the rest of the material, what they're doing, either they're putting it into the drain or they're putting it into the dump here. So as a matter of fact, this is creating the problem in the air, this is creating the problem in water and also the soil. So there must be a very good e-waste recycling collection and plans in India, and it is possible. The other thing, the rules have given a lot of advantage for us, that today the EPR, there are always the manufacturer who has to give an EPR plan that how much material. EPR is extended producer's responsibility. That means if you produce, you have to rather, if you produce, you are the responsible person or the organization to take it back and take care of the pollution which is generated from the waste. So in that way, the generator, the producer of the electronic and electrical equipment, they're responsible for giving the EPR plan at the beginning of the year to the government, that this much of percentage of the waste, this much percentage of the material which we are selling will be collected by us at the end of its life, and then we will recycling it. And it started working in India. But you know that the cooperation of the manufacturer, the cooperation of the user is needed very much to implement the EPR. Of course, for the collection and recycling, there are PROs who are responsible for recycling, collection and recycling of this electronic waste. So these are all available in US Recycling Rules 2016, but these are all good opportunities for making US business in India. So this is a plastic, breaking the plastic web. I have just taken it from some of the slides from my friend. And you know that plastic is also are very good business opportunities. And one thing we have to keep in mind that plastic, most of the plastics are recyclable. So in that way, we have to be careful that plastic should not be disposed in the nature, rather on the roadside or water bodies, because plastic today is one of the dangerous material which are creating problem in the society, in the environment, and not only in the society, land and environment, but also it is creating problem in the marine life. And you know that out of this plastic, the microplastic is generated with time, and that is dangerous because those microplastics in the size of micron and nanoplastics, those are swallowed by the mammals and also fishes. And ultimately, whenever we are grabbing those, these are all coming back to our stomach and creating problem. I mean, some of those are carcinogenous. So in that way, you know that the percentage of the cancerous people are increasing day by day. One of the reasons of those are the microplastics. So we have to be very careful about that. On the other hand, we have to have design the material in such a way that recyclability is more and the material must be robust. I mean, we have seen there are a number of business models like out of these plastics, waste plastics, the governments, other products are also prepared. So in that way, we have to be very careful about that, and the science and technology must take a bigger role for this. And yeah, these are all microplastics which I was telling. And then let us come into what is circular economy. So whenever I discuss the circular economy, I take one of my definitions. This definition is on circular economy. Though we have to understand very carefully what is circular economy. It's a system level approach for economic development, and it's a paradigm shift. What is our concept today? Our concept today is a linear concept. What is the linear concept? EPCD2. EPCD2 is E is you are extracting the material, P is you are processing the material, you are producing the material, I mean, for some product. And C is once you produce the product, you are consuming the material. Then the D is after you consume the material, at the end of its life, you are disposing the material. Now the question is how to dispose? Because that depends. You dispose it to the landfill, and disposing to the landfill means you are depleting the natural resources. So in that way, this EPCD2 is not a sustainable process. So this we call linear economy. So in the linear economy, we have a EPCD2, extract, produce, consume, dispose, and deplete. So from this, I mean, if we have to go to an elevated echelon. In my word, it is elevated echelon of achieving zero waste. How? It will conserve the resources, and how we can conserve the resources and achieve an elevated echelon of zero waste. We have to change the concept of design. Change the concept of design. And what is the concept of design? Design of the production process, design of the material for higher life cycle. Design of the production means you reduce all the consumption in the production, like reduce the energy involvement, reduce the material requirement, reduce the weight of the material, reduce the waste of the material from the production, reduce the energy loss from the material process. So all this, so you have to design the production process and the product as well as the raw material, which needs a higher life cycle, and conserve all kinds of resources, energy, water, material, machineries, utilization of machineries and everything. And material energy recovery all through the processes. Even if there are loss of the material, you must recover those. It's energy loss, you recover it. Heat loss, you utilize the heat for other purpose. Material loss, you either recycling in your process or give it to other process. So at the end of the life cycle for a specific use, if you use a pen, a writing pen, then its specific use is writing with the help of a pen. So when the pen use as a pen is over, what? Don't throw it away. So the design should be such that the product will be still fit to be utilized as an input material to a new production process. Means if you are utilizing as a pen, then give it to the recycler, they will shred it and they will recycling it, and maybe they will make a bead or they will make a decorative material. So this material again will be sold in market. So this way you creating the value chain with a closed loop material cycle. So you are not throwing it away. Once the material is extracted from the natural resources, once the natural resources is extracted, what you are doing, you are producing it, using it, and dispose in such a manner that that particular material acts as an input material to the second process. Then again, input material to the third process. That means you are not disposing to the landfill site. So what helps? In which way this will help in reducing the extraction possibilities? 2, extend the life cycle. 3, it's a closed loop cycle, improves your resource efficiency, resource productivity, and it creates, in each of the processes, it creates a business possibility. And this business means it helps society, it creates employment opportunity, and ultimately it's provide an environmental sustainability. So this is circular economy. So the circular economy saying is very easy, but practicing circular economy with this concept is not a very easy job. Of course, you must have the planning for that. Like what is the concept converted into? That ensure the useful application of the material by recycling, recover, then extend the lifespan, reuse it, repair it, remanufacture, repurpose it, and then smarter product use, design manufacturing procedure, extended responsibilities, and all these things. So this is the one thing in India. What we started, where we started in 1970, just pollution dilution. All the factories were there. They were not interested to take back the material which is lost. So lost material means lost. They are putting all the effluent in the Ganges and other rivers. They are putting all the waste into the dump site and creating a lot of problem. And then what is the end of pipe of solution? Clean production technology came later on. And then, of course, the industrial symbiosis, then sustainable consumption and production. And today, we are going for the circular economy and resource efficiency and industry 5.0. And with this, we have a robust reverse logistics. And of course, the waste leakage is to be stopped with this circular process and closed loop cycle. And of course, in this circular economy, you have to look into 3 things. One is the cycle of the product, cycle of the material, and cycle of the parts. So not a single one should be disposed of. Each of these can create the value for the customer and create a value chain. So we should be concerned about what value chain we can create, and the intervention of the technology acts in each of the places, how the product life cycle can be extended, how the materials life cycle can be extended, how the material can be utilized and can be recycled once the material is not in a position to be utilized, how the product can be refurbished, how it can be maintained properly with the maintenance. And ultimately, this should come to the zero emission, zero loss of energy, and on the above all, it should come to as a sustainable developmental goal support. And this is one of our model. Like whenever we talk about circular economy or recycling, we should be we should look into the aspect of at the very initial stage, whenever at the conceptual state, that what is the design. So it should be started from the design point of view. When it is in conceptual stage, we must start from that only. So that if we talk about that we will recycle the material for time and again, it will not be possible because the recyclability of the material should be there. So the material can be recycled for time and again, when number of times, if the material is designed properly so that it can sustain its properties, most of the properties after recycling. The second thing, eco-design of the products. So eco-design of the product, the material should have, the material which we will design, it should have long life, for life extension should be there, and fewer resources should be used. So all these things must be there whenever we designing a circular economy process. In that way, we must have the scheme for designing the circular economy process. It is not easy. It is easy to say that we are going for circular economy, but importantly, we must design the process, product, and material to achieve the circular economy goal. And there are a number of options. I'll come back later on. So that I have the research on circular economy with more than 44 countries throughout the world. And I can see that I have divided these countries into 4. One is matured circular economy driven society, progressive circular economy, initiated, and not initiated. So in most of the cases, we have seen that they fall under these 2 categories, not initiated or just initiated. Like, then what's about Asia? In Asia, there are only a few countries. There are only few countries where we can see that the circular economy is working, or they are trying well. One is India, second is China. They are in the second stage of progressive C-driven. But who are the matured? Japan, South Korea. These 2 other countries who are in Asia going ahead than other countries. Like if we talk about Europe, you will find that there are many countries who are at par, like Norway, Germany, Austria, France, Italy. They have a matured C-driven society, and as a matter, UK, and as a matter of fact, we have seen that they have achieved a lot, and there are a number of employments and also success stories with respect to the implementation of CE. What about India? I was referring to that we have 6 rules, like these are the rules. Solid waste SWM rules, plastic waste management, e-waste, medical waste. So all these things were released in 2016 and this battery waste rule 2020. Those who are interested and working on waste management and circular economy, I'll request them to please download these rules and read those. There are a lot of learning and a lot of points for us as a general citizen to be responsible to, like solid waste management, how this can happen. What we do, we mix the waste and throw it away. We mix the waste and hand over to the waste recycler. No, the first responsibility comes from us as a general citizen. What is that? Separate the waste. If you go to Germany, if you go to any of the European countries, you will find, even Japan, you will find that they are separating the waste. They are separating the waste to as maximum as possible. There are a number of bins, and even the kid of 3 or 4 years knows very well that which material has to be put in which bin. So this is the first activity by which your waste management can be made effective. The segregation of waste. I'll request all of you to please enrich your students, your kids regarding the segregation of waste. If the waste is segregated at source, then many of the waste management problem is solved. If it is not done, then all the problems is lying in the society. Like why it is required. If you segregate the waste at source, then the recyclability of the waste is becoming higher and higher. If it is not, like say all the types of plastic, paper, metals and other things you are mixing and you are handing over to the recyclers, what they will do? They have to separate all the types of waste at their end, and then they will go for recycling. So what does it mean? That means they are incurring some cost which could have been done at the source at no cost. So if this type of cost is involved, then ultimately the waste management cannot make a business case. So if it does not make a business case, means waste management will be a problem in the society. But for your intervention, the very small intervention at your home and at your waste generation center, if it is happening, then the rest of the part is very smooth. Like if you, in India, you go to Indore, in Bangalore, some of the places I can see, Yalanka and others, they're doing very good. They're separating the waste and they're doing good business. But it should be done. And the technologies, there are a number of technologies, and I'm quite sure there are a number of researchers and professors who are attending this program. They develop a number of technologies. All the technologies can be sustainable if the feedstock is good. If the feedstock is not good, then the technology will not work at all. So the policy intervention, the intervention of the waste generator is very, very important for implementing any technology of waste management. Let us see what is innovation. This is one of my machines. So before I go to that, I want to show you one. I'm just leaving this sharing, and I'm sharing some other this thing. Just 1 minute. Give me 1 minute. Yeah. So I'm now sharing one video of 6 minutes. And this is a concept of plastic waste, how this plastic waste can be, are are being carried out in dumping yard in Kolkata, the biggest, one of the biggest dumping yard in Tapa, and how people are collecting those waste for their livelihood earning. And those were converted into a valuable product. I made this machine and I got the patent for this machine, and there are a number of municipalities and small entrepreneurs who were working with this machine for making a valuable product and also a business with this waste. So let us see and enjoy that. This is a 6-minute video. Can you see the screen? The screen can be seen?
Yes, sir.
Okay. Oh, just 1 minute. Yeah.
में भी छांटने और चुनने का काम करने में व्यस्त ये लोग प्लास्टिक की खोज में आते हैं। कबाड़ी वाले के पास से होते हुए ये वर्ज्य प्लास्टिक चला जाता है विभिन्न रिसाइकलिंग सेंटर्स में। कोलकाता में इस तरह के प्लास्टिक रिसाइकलिंग सेंटर्स की संख्या करीब 1500 है। ऐसे रिसाइकलिंग यूनिट जहां प्रतिदिन 12 घंटे की शिफ्ट में करीब 500 किलो रिसाइकल्ड प्लास्टिक का उत्पादन होता है। इस कारण के तौर पर इस कारखाने में वज्र प्लास्टिक के टुकड़ों में तोड़ा जा रहा है। इस दौरान शब्द दूषण अकल्पनीय होता है। इसके बाद विभिन्न जगहों से लाए गए इन प्लास्टिक के सामानों को पानी से धो लिया जाता है। इस कार्य में किए जाने वाले हौजे का आकार भी इतना छोटा होता है कि जल की मात्रा भी पर्याप्त नहीं होती।
So that this green recycling process, which have been developed in this research project at our mechanical engineering department with the help of Central Pollution Control Board, New Delhi, and our Center for Quality Management was also associated in this research project. Now this machine gets its power from this power source. Through this power source, it comes to the control panel as well as it goes to the whole driving system. This one is the driving system. Now this control panel is having different thermostats which controls very minutely the temperature at each of the zones of this barrel. There are 4 zones in the barrel. Now, whenever the motor over here gets the power from this power source, through the pulley, the gearbox is driven, and from this gearbox, the screw inside the barrel is driven. So, in this barrel, the material is fed through this hopper. Now, this hopper gets the material which are waste plastics, and we clean the material, sort the material, then we take the material from this hopper to the barrel itself. Now, you know that the first place where the charge is made is the barrel charging zone, where the temperature is around 100 to 150 degrees centigrade. I'll tell you the temperature of these different zones are depending on the material itself, whether you are using LDP, LLDP or PP. Now, from this charging zone, the material goes to the transition or compression zone. This is the point where the temperature varies from 150 to 175 degrees centigrade, and this material goes to the melting zone or metering zone. This is the transition part that material goes to the liquid stage. Now, through this liquid stage, the temperature raises to 225 to 250 degrees centigrade in the dye zone. Now this dye zone gets the material in melted condition, and through this breaker plate, it goes to the dye itself. Now you can see that the whole dye, the dye divides the material flow into 8 circular cross section. It can vary, you can have it 6 or 10. Now this material through this cooling system goes to the cutting unit, where from we are getting the granules. Now let us come down to the pollution which are generated over here. Now this pollution to the atmosphere are really dangerous for the people, environment, and including the person who is working as an operator. Now we have taken the whole of the material through this duct to the system which we call our pollution control device. Now this pollution control device at its end is having a pollution treatment device. The uniqueness of this process is the whole of the pollutants treated in such a manner that we can make the byproducts out of these pollutants. So this process, whatever pollutants it is generating, this is the process. You can see the treatment zone, the zone where the pollutants are being treated, all the gases, and also the pollutants are converted into usable chemicals. Now, what we are releasing to the atmosphere through this is very much pure, and 95% of the pollutants generated in the process have been recovered and eliminated. So as a matter of fact, this process is very unique in nature, and this is the first in our country, the process which can be adopted by the recyclers of our country. You know that this is one of the most unstructured business area, which involves a lot of products. These products are having very good market in our country and abroad also. So if
So this is the thing which you have seen. I'm again coming back to my so this is the machine which you have seen earlier, and just 1 minute. Yeah. So second thing, you know that there are a number of innovative ideas which are carried out in different parts of the world. Like these are all, you know, that carpet. So now these carpets, which are treated in such a way, which is a petroleum-based polypropylene, and a new solvent is now making it possible to recover the virgin standard polypropylene from this carpet waste. So now this polypropylene carpet waste is again creating virgin material with the help of which we can again produce plastic materials. And this is still under project mode. And in 2022, this will be taken care of. I mean, the pilot project will be done by this ISO-PREP-EU project. And this is one of the very important projects which you can look into it. This is also available in the website. Another thing is cooking, using cooking oil, a renewable fuel, like hydro-treated vegetable oil, we call it HVO. Again, this is another innovative idea using the technology, which is again also project mode. And McDonald's in Netherlands has joined hands with Neste and logistics companies Heavy. They will set up a circular process unit by which they will produce this HVO. And municipal waste becomes jet fuel. And many of you also know that this is another intervention. I mean, from the municipal waste, we are utilizing these in biomethanation and other plants. But this is becoming a new thing which will produce fuel for the jet. And some aviation company is taking care of this project, and they will, in 2020, we are expecting the product to come in the market soon. So there are other innovative projects which are there in waste management. I'm not going to this, and now I'll go to, look, this is, I mean, you know that Bangalore tried to have the waste to energy plant, but you know that there are a group who does not like waste to energy plant, but the recycling. Of course, recycling other than waste to energy plant in India is preferred. I also like that. But on the other hand, this waste to energy plant, if you make it properly, then see the business model, because you know that you have to also look into what is the business of a particular activity. If it is not sustainable, then it will not long for long time. You see, this is a plant which I visited in 2015. Yeah, the Covanta. It's near Philadelphia. You know that this plant is generating 80 megawatt of power by utilizing only 3,510 tons of waste per day. Out of 3,500 kg of tons waste per day, it is creating 80 megawatt power of plant. So this is a good business model. And you know that this waste, these are transported from different cities by vehicles and railway wagon. So this is the way this business is running. And also, there are only few people who are working. So this type of activity, like I have seen one project in Bangalore, you know that this will be really a good project, that the market waste is collected. It's not in Bangalore, it's in Mysore. The waste is collected from the market, the green vegetables and others. Then there is a number of cattle. So they chop it and give it for the cattle feeding. So this vegetable waste is converted into manure in 24 hours by this cattle. So now this dung of this cattle is taken to the biomethanation plant, and then it generates gas. So in that way, this is a high valued, contain the content. So in that way, this biomethanation gas, this is used as fuel in kitchen. So in that way, the waste, vegetable waste, is converted into fuel within 48 hours. This is not possible in a biomethanation plant. So you take the biomethanation plant, take the vegetable waste, put it in the plant, it will it will go by its own process, and it will take some time to generate the gas. So on the other hand, what happens? You are not wasting the value of the vegetable because you are feeding the cattle. So in that way, there are two purposes which are served. I was really very pleased to see this process. I don't know whether this is still running in Mysore. So this e-waste, let us forget it. I was just searching this photo that in mobile, there are a number of things which iron, then vibration motor, ceramic, AG is there, then AU is there. So these are very high valued material. And other than high valued material, there are other things, copper is also there. So I showed already. And you know that hydrometallurgical recycling of spent PCB. PCB, again, I'm telling that electronic waste, plastic waste, construction waste, these are high valued material for recycling process, and the recycling value chain is higher than other wastes. Of course, industrial waste is also. So this is one of the process. I believe that many of, some of our friends in this, whenever they talk about e-waste, e-waste, they will discuss all these things. Then pyrolysis, another plant. I have recently received a project on pyrolysis from India, Hungarian project, and we are setting up one pyrolysis. Of course, pyrolysis plant, of course, it's good, so small. So we are pyrolyzing biomass and the plastics. So this is also a good process, but the cost effectiveness of pyrolysis process in our country is still in question, but this gives fuel, solid char, and also some liquid fuel. So then comes this, okay, there are a number of raw materials, forget it. Tire is also one of the input material. Okay. So low carbon manufacturing. Yeah. So you know that we need to go for carbon-free future. And Google has a plan that by 2030, they will go for carbon-free future for 24/7. This is also the utilization of renewable sources. Renewable sources, one is air, other is sun, and the third is waste to energy. What are the technologies? If we look into this figure, we'll find that there are a number of technologies which are involved in waste management and waste processing. If we took wet waste, there are a number of technologies. Biomethanation, we can use produce biogas. If you go to Indore again, I'll tell you that they have a plant of 20 tons per day of market waste. And what they're doing, they're generating biogas and they're refining it and they're putting it into the cylinder and they're supplying it to government buses, and the government buses are plying on road with the help of this biogas. If you go to Pune, if you will find that there are a number of biogas plants, 5-ton and 10-ton biogas plant, with the help of which they are generating electricity and putting the street lights on this biogas. Vegetable waste to compost. Compost is not a new technology. This is a very, very old technology. And I'm quite sure that in your place, each of you, in Bangalore, there are a number of, Bangalore has a very good decentralized waste management. And from this Icon SWM, Bangalore has received number of awards in number of times. So composting also helps in combating the waste management. But thing is that quality of compost, we must be very careful about that. The content of heavy metals, we have to look into it. And the quality control of the composting process also is very either, whether it is vermicomposting and whether it is windrows, but vermicomposting is better product turnover than the windrows. However, pyrolysis, gasification, in absence of gas, oxygen, then RDF is another, I'll come back to that. And you have a separate lecture on this RDF and on the co-processing. Then incineration. And if you take about dry waste, there are again number of recycling process. One of the recycling process I have shown in the video, that's a recycling process. And the beads which you have seen, the yellow beads, it can be any color. That can be again used for producing number of plastic products like what you see in the market. And in India, we have a huge market for the recycled product. Then you can go for road making by blocks. Again, pyrolysis, co-processing, and there are many other individual recycling processes. So forget it. There should be a symbiosis of the technologies. Now the last part is co-processing of waste. Simply, what is co-processing? In the cement plant, you are taking the waste into the cement plant or any other kiln, and with other fuels, you can also add some fuel, or standby, you can take this fuel only by substituting either coal or petroleum coke or any other thing, conventional fuel. So whenever you are substituting conventional fuel by other fuels, here it is waste, it is co-processing. And the main important part of co-processing is whenever you are utilizing waste in a cement kiln, you will find that a part of the waste is converted into energy, which gives heat in the kiln, and the rest of the part, I mean the organic and non-organic, the other part, it converts into not the ash, but it converts into clinker, and finally it produces cement. So we call it TSR, total substitution rate. I mean, how much it can substitute the fuel. And here, if you give the fuel, the waste, this is converting into the energy and the raw material by 100%. So there is no waste, no residue. So that's why we call this co-processing of waste as AFR. AFR is alternate fuel and raw material. So this is the cement plant.
Excuse me, sir. Sorry.
Yes.
Running short of time. Can you please wind up?
All right.
Thank you, sir.
So these are the materials which can be used in co-processing. Number of materials which can be used in co-processing. And let us forget all these things. And this is a Swachh Bharat and Swachh Sarvekshan that I was telling about 4,242 cities. And in the conclusion, you have to reduce the waste. You have to utilize the waste. And ultimately, you have to reduce the extraction as well as dumping into the dump site. And you improve the waste management using 3R, educate people, promote eco-friendly alternatives, and through technology, a regulatory framework, and of course, the EPR, the voluntary participation. And for that, we need legislation, different technologies, triangular cooperation among government, industry, and academia, research organization, research and innovation, and lastly, the desire to make the environment clean. So with this, I put aside my technical presentation. Now, all of us, I cordially invite to attend and submit your articles to 11th International Conference on Sustainable Waste Management and Circular Economy and IPLA Global Forum in December 1 to 4. And this will be attended by around 45 countries this time. And your abstract and full paper may be submitted by 30th of September. And this is the link. It will be also available to you because Jyotir Lakshmi is also one of the secretariat member of this conference committee. So she will circulate it to you, and this will be a very good conference. And we publish these papers, selected papers in special issue of journals and books, Springer and CRC Press. So with this, I once again thanks to the organizer as well as the participants for your patient hearing. Thank you very much, and over to you for any question.
Dear participants, if you have any questions, you can ask now. You can unmute yourself and ask. Okay.
I think some questions are given in the chat box. So
yes,
if the secretariat can take up this.
Yes, sir. It's written, it's by Amit Rathod. Can it is possible to restrict manufacturing of below 50 micron plastic?
Yeah, Amit Rathod, you have rightly pointed out, because you know that this 50 micron of plastic, it cannot be stored, manufactured, and sold and used. It is in the rules. There are many places where these rules have been implemented. Government and civil societies are also trying to achieve this. But you know that in a country, in a democratic country where the number of population is 135 crore, is really very tough unless and otherwise there is a very strict governance. And again, if there is strict governance, then also again there will be a problem from public. So in that way, it has to be restricted, and it is taking place, the restriction taking place, but of course it will take some time. On the other hand, not only 50 micron, India government has announced by 2022 they will reduce the single-use plastic, but I think that it will take some more time to make a practical and feasible planning of this, stopping this 50 micron plastics as well as the single-use plastic. Thank you, Rathod.
Any other questions from participants' end? Yeah, one more question, sir, from Samir. Rag packer is key for collection of waste. How can we accommodate them in waste recycle bin chain?
Yeah, Samit, this is also a very good point you have raised. Like, yeah, you have rightly pointed out, because you know that that is also in the rule, and in many of the cities, it is being carried out. I mean, I have seen in at least 4 or 5 cities, in Chennai, someplace, in Indore, even in Bangalore, these rack pickers are taken into the mainstream in the recycling process of organized sector, and they have been given the wages package and dress, then health card and all these things. But we have to accommodate them in the recycling chain, and then only it will be a solution for the waste management. Rack pickers who are collecting these, they have to be trained, and some NGO and the municipality, they have to take the steps for taking them together and assuring them that because you know that rack pickers work for their livelihood earning. So if they get their livelihood earning in a decent manner, they will be really interested. And I have seen in some of the places that hundreds of rack pickers are taken into the mainstream recycling process, and they're doing very good work. But there is a huge scope in our country to do that. That's a good question, and I appreciate if we can do something for them. Please. When we recycling certain materials, this may result in emission of the poisonous gases. Is there any possibility or technology to reduce minimum? Yes, Mr. Tejas, MS. You know that we call it a technology when there is no problem in the technology with respect to the production. I mean, all this sustainability. One is the operation, 2 is environmental, 3rd is economic, and 4th is the social. So if we use the technology, there are a number of technologies. I mean, if you can specify which technology, I can tell you. because all the technologies are there where the emission level is now controlled, because emission level is a very important entity in the society as well as in the government. There are rules. So there are a number of technologies for the recycling of any material which I talked about this morning. This is possible with the emission under control. But thing is that what happens that many people or the recyclers, they use technology which is not sustainable, which is not even developed by some scientist or something. They go by all these technology which are very old and all this rotten technology. So those are really creating problem with respect to the emission of the poisonous gases. But we should take care that the right technology is used, and if right technology is used, there are no harm in the pollution. But on the other hand, we have to look into the social responsibility. You know that there are many factories, small and medium, who have ETP or who have good emission control system. But you know that they think that these are costly, these are expensive. That's why only whenever the regulator comes, they operate it and control their emission. But when the regulator goes away, they start again emission. So these are social responsibility. So unless and otherwise we have socially responsible person, it is very difficult to control the emission. But technology is not at all issue. The problem is we guys who are using this technology in a bad manner. Thank you.
Dear participants, do you have any other questions?
Good afternoon, sir.
Good afternoon.
Sir, I'm Prabha Sudhan working on removing the microplastics from the water. Sir, do you think it's a serious problem in microplastic in drinking water, packed drinking water?
Of course.
But there is a data saying, World Health Organization saying it's not harmful to humans in below 500 or 200.
Look,
there is a limit.
Yeah. I'll tell you.
Okay.
You know that the physics is yours. Okay.
Okay.
Who sets the limit? People like us, scientists, set the limit.
Yes.
So the setting the limit again depends on many factors. One is the technology availability, the exposure, and the economy. Always the set limits are set based on these three, right?
Okay.
So there are harm. If you can avoid this, that is the best way for your health. And on the other hand, you have an option that go by the limit. So in that way, there is a limit. You can obey that, but it is always better to avoid that if it is possible. Got my point?
Yes, sir. I got another question, sir.
Yeah, please.
Sir, where I can collect the data of health problems due to microplastics in India?
Very tough. Health problem. Don't forget about India, because health problem for microplastics is an international issue.
Okay, sir.
Right. Microplastics does not see whether you are in India or in other country.
Okay.
Got my point. So in that way, wherever it is available, you take up that, and you can contact me for some of the valuable links and other things.
Okay.
Because the data management is again another issue for microplastics. You won't get a lot of data and for microplastics health, but you have to search it. I'll also give some of the links so that you can get some data.
Okay. Thank you, sir.
Thank you.
Okay, any other participants who want to ask questions? Okay, I guess no. Thank you, Professor Sadhan Kumar Ghosh. Thank you, sir, for accepting our invitation and delivering an informative session talk on waste management. Thank you, sir. On behalf of Department of Mechanical Engineering, I thank you once again.
Thank you. Thank you.